All right, let's get ready to review for the second semester final exam. I am going to make 8 short videos going over the review packet. So we'll get started with page 1. So first of all, the question 1 says, how many electrons are lost or gained when you see each of these ions here? So let's do a little refresher. Magnesium is number 12 on the periodic table. What that means is that it usually has 12 positive protons, and if it's a neutral atom, it has 12 negatively charged electrons. 12 positives and 12 negatives adds to 0. But what can happen is, if you remember, metals tend to lose electrons to form a noble gas configuration in their outer shell. So for example, magnesium's number 12 is very close to neon's number 10. So it would like to lose 2 electrons to be like neon. So when that happens, when you've got 12 positives and only 10 electrons, now you've got a +2 charge. Similarly with bromine, bromine's number 35, it would like to be like krypton. So it would like to gain 1 electron. Normally it has 35 protons, 35 electrons. Well, krypton has 36 electrons. So if it gains that extra electron, now it'll have a -1 charge. And then you can kind of, once you've got that pattern thought through, you can say, okay, silver's got a +1 charge. That must mean that it lost 1 electron. Iron's got a +3 charge. That must mean that it lost 3 electrons to form that charge. The protons are winning. Moving on to number 2. Number 2 says, classify each of the following as covalent or ionic. So first let's do a little refresher of what the difference is between a covalent compound and an ionic compound. Covalent compounds are made of all nonmetals. That is things that are to the right of the zigzag on the periodic table. Ionic things are metals and nonmetals. So one thing to the left of the zigzag and 1 or more things to the right of the zigzag. So then you have to look at each of these compounds and figure out if it's all nonmetals or if it has a metal. Carbon and oxygen are both to the right of the zigzag line. So that means that this is covalent. On the other hand, sodium is on the left of the zigzag, chlorine's on the right, so that must mean that this is ionic. It's got a metal and some nonmetals, and a nonmetal. Same thing here, metal, nonmetals, so that one's ionic. 2 nitrogens, those are both to the right of the zigzag, that's covalent. H2O, technically hydrogen is to the left of the zigzag, but it's the exception. Hydrogen is definitely a nonmetal, so this is another covalent compound. Number 3 then should really kind of come before number 2. What types of elements tend to combine to form covalent compounds? That's nonmetals. What exactly is a covalent bond? This is when electrons are shared. That's why when we're drawing pictures of covalent bonds like HCl, for example, we always show that there's this line connection between the 2 electrons. Hydrogen would really like to have 2 electrons to be like helium. So it shares chlorine's valence electron, so it kind of feels like it has 2. On the other hand, chlorine would like to have a noble gas configuration like argon, so it feels like it does when it shares an electron with hydrogen. What types of elements tend to form ionic compounds? So again, this is metals and nonmetals. What exactly is an ionic bond? Well, let's take an example like sodium. Sodium has 11 total electrons. It's got 1 valence electron. Chlorine has 35 electrons. It has 7 valence electrons. So it would really like to gain 1 more. So what happens in an ionic bond, since this metal would like to lose its electron, it does. So sodium totally transfers its electron to chlorine, and now because it lost 1 electron, just like in number 1 we were talking about, it has a +1 charge, this atom. Chlorine, because it gained 1 electron, now has a -1 charge. And as we know, opposites attract. So an ionic bond is really an attraction of oppositely charged ions. Number 5 makes it seem like you're going to have these memorized for the final, but they're actually on your solubility table. So just for practice, carbonate is CO3 with a -2 charge. Sulfate is SO4 with a -2 charge. Phosphate is PO4 with a -3 charge. Nitrate is NO3 with a -1 charge. Hydroxide is OH with a -1 charge. And ammonium is NH4 with a +1 charge. So it's a lot easier if you have these memorized, but it's definitely not necessary for the final. Number 6, writing formulas. This is all about crisscrossing, except for the first one because the charges are going to cancel out. So magnesium's in group 2A. That means it would like to lose 2 electrons and form a +2 charge. So write the charge above each element. Oxygen's in group 6A. It would like to gain 2 electrons. So since +2 and -2 cancel out and make 0, the compound is just MgO. But if you've got something like sodium, which wants to form a +1 charge, and sulfide, which would like to form a -2 charge, you need to crisscross those numbers. So ignore the charge, and then kind of do like a zigzag, or not a zigzag, but an X. So Na2, and then you don't need to write the 1, but it's there, S1, so this compound is just Na2S, sodium sulfide. So then it's just kind of over and over again the same sort of thing. Potassium iodide, these charges cancel out, so it's just Ki. Aluminum chloride is a little bit different. +3 charge for aluminum. Chlorine's got a -1, so this becomes AlCl3. You don't need to crisscross that 1 over. Tin 2 fluoride. That means tin has a +2 charge in this compound. Fluorine always has a -1. So this will be SnF2 for a final answer. Iron 2 nitride. Iron is Fe with a +2 charge since it's Roman numeral 2. Nitride is a -3 charge always. So this becomes Fe3N2 for a final answer. Then the last part here kind of makes it even easier. It shows you what the charges are, so you just need to crisscross. BaCl2, +2 and -2 cancel out, so that's an easy one. Al2O3, once you crisscross, these cancel out. AgI, same here, KBr, and iron 2 oxide, those cancel out, so you can just write FeO. Alright, number 7. Which 2 subatomic particles contribute to the mass of the atom? You may remember that only the nucleus really contributes to the mass, and the nucleus is made of protons and neutrons. So those are the only 2 things that contribute to the mass. Now, how about the charge? Well, neutrons, remember, just like they sound, they're neutral. That means they have no charge. And you can remember P and P, protons are positive, and therefore electrons are negative. That's going to help us out with this bottom part here. So filling in this table across, let's look at magnesium's spot on the periodic table. We're really looking for the number at the top. Since magnesium is number 12, that means it always has 12 protons. Protons tell you the identity of an element. Now, this particular isotope has a mass of 24. If only the protons and neutrons are contributing to that, that must mean that there are 12 neutrons. So, mass number minus the number of protons is always equal to the number of neutrons. Now, what about electrons here? Normally, if it's number 12, it has 12 pluses, positive protons, and it has 12 negative electrons. But this one has a +2 charge, so that must mean that it's lost 2 electrons to have the protons be winning. So 12 positive protons and only 10 negative electrons would make the positives winning by 2. So that must mean this is a 10. How about the second row? It doesn't tell you anything about what the element is. But here's our identity right here, 15 protons. That automatically makes it phosphorus. How much does this phosphorus weigh? Remember, protons and neutrons are the only thing that contribute to the mass. So 15 plus 16 is 31. And then if there are 15 pluses and 18 minuses, this must mean the electrons are winning by 3. So this becomes P3 minus. Now we're on to naming ionic compounds. Remember, you only need Roman numerals for transition metals. Transition metals are that block that's between 2A and 3A on the periodic table. It goes from number 21 to 30, and that block all beneath it. So how do you tell what the Roman numeral is going to be? Well, you look at what it's bonded to. Oxygen is always a -2. That means it wants to gain 2 electrons. And here we have 2 of them. So -2 times 2 is a -4. That must mean that these oxygens are gaining 4 electrons from the manganese. So manganese is losing 4 electrons. If you lose 4 electrons, what's going to be your charge? If you lose something negative, I always say in your life, you're going to be more positive. So manganese is going to have a +4 charge. That means that its name is manganese, Roman numeral 4, oxide. Okay, then let's go down. This one's an easier one. Calcium is not a transition metal, so we just get to name this one calcium chloride. Oops. Don't mind my computer there. Alright, what about letter C? This nickel is attached to or bonded to 2 chlorines, each which has a -1 charge. So -1 times 2, that's a -2 charge. So that must mean that this compound is nickel Roman numeral 2 chloride. Sorry about my computer screen there. Alright, what about over here, letter E? SrBr2, this should be a simple one. There's no Roman numeral necessary because strontium is not a transition metal. So this just becomes strontium bromide. Same here. Potassium sulfide. You don't need to do any work because potassium is not a transition metal. Copper is, though. If copper is attached to 2 negatively charged chlorines, that must mean that copper has a +2 charge. So this would be copper Roman numeral 2 chloride. Alright, then it wants you to write some compounds crisscrossing, and it has polyatomic ions. So this isn't really harder than what we were doing before. It's just using the polyatomic ions. So Na has a +1, PO4 has a -3, so this is just Na3PO4. Sodium hydroxide, Na has a +1, hydroxide has a -1, so that just cancels out. That's done. Magnesium sulfate. Magnesium's got a +2. SO4 sulfate has a -2. So that's just done. Those cancel out. Potassium nitrate. K is a +1. NO3 is a -1. So those just cancel out. Ammonium chloride. NH4 has a +1. Chlorine has a -1. So those just cancel out. And finally, potassium carbonate. K's got a +1. Carbonate has a -2. So this would be K2CO3 when you crisscross that 2 over. Finally, it gets a little easier on this last one, and all it wants you to do, at least for these first two, is crisscross again. So this first one becomes NH4 in parentheses 2 SO4, because remember, otherwise it would look like 42, when really it's 2 ammonium ions. That's why you need parentheses. You need parentheses anytime there's more than one polyatomic ion. KNO3, this is a repeat. That was in the question above. Barium hydroxide. Barium's got a +2 charge. Hydroxide's a -1. So this is BaOH2. Remember, you need parentheses because it's more than one polyatomic ion. And finally, lithium and carbonate. Lithium's a +1. Carbonate's a -2. So this is Li2CO3. That's it for part